This is a nucleus X which is unstable, and if a slow moving neutron hits with it at a certain energy, it will absorb into this nucleus, it will destabilize it. It is already unstable, but it will break it into the two fragments, let's say the nucleus Y and nucleus Z, which are smaller than the, as comparable to the size of nucleus in proton and nucleon number, as comparable to the nucleus X. So in this question you have to compare the binding energy of this, binding energy per nucleon of this nucleus X, Y and Z. Now, what is a binding energy per nucleon? It is a decisive factor which determines the stability of the nucleus. For example, if we see this graph, binding energy per nucleon versus the nucleon graph, as you see, we have taken the nucleon number on x-axis. So the most stable element in the universe, according to this graph, is the iron. Why? Because its binding energy per nucleon is 8.8 mega electron volt almost, which simply means that if this is a nucleus of iron and this is a one nucleon, a proton or a neutron, and you want to take this proton or neutron out of the nucleus, you require 8.8 mega electron volt energy. Whereas, let's say the element, this is element X, which is a heavy element. So we assume that this is an element, nucleus X. So when it will break, all the heavy nuclides, when they break, so they break to achieve the stability, because this is the stability region where the stable element lie. So any heavy nucleus always performs the fission reaction to get the stability, because as a result you will get those nuclides which will have a nucleon number less than X. As you see, these are closer to the stability region. For example, in the case of, like, if we take a practical example, so we can compare our this question with this reaction. You can consider uranium as a nucleus X. It is dividing into the barium 141 and krypton 92. So of course, and with the emission of the three neutrons and some energy. So don't you think that the binding energy per nucleon for barium is more than binding energy per nucleon for uranium, as well as for krypton it is more than uranium? Because both of these elements, fragments, barium and krypton, exist above the uranium on this curve, and hence they have a more binding energy per nucleon. They are more stable. So as a result, the Y and Z both will have a more binding energy than an element X. So A is the right answer for this question.